going to talk about linear and rational equations. So I know that you've had lots of practice solving linear equations. You've done them in many previous algebra courses. But just as a brief review and practice, solve these two linear equations, discuss in your groups if you get stuck, and then we'll move on after that. Okay, so for the first one, we want to gather all the x's to one side and the non-x's to the other side. So I think maybe I'll subtract 4x from both sides, so I get 5x on the right. And then I'm also going to add 13 to both sides so that I get 20 on the left. Everybody with me? Okay. Then divide both sides so we get x equals 4. Is that what other people got? Okay, good. So the solution set is we put in curly brackets. You want to list all the values of x that can make that equation true. In this case, there's only one, so we say the solution set is 4. Just 4. And then we check it by plugging the 4 back into the equation and making sure we have a true statement. So I do 4 times 4 plus 7. Does it equal 9 times 4 minus 13? 16 plus 7 is 23. 9 times 4 is 36. Minus 13 is 23. Check. 4 is in fact a solution. Because when you plug it in, we get a true statement. Okay, so B is a little bit trickier because we have some parentheses to deal with. So we distribute first. So I have 3x plus 6. And then I have 10, and I'm going to distribute a negative 5 here. I'm going to distribute the negative sign with the 5. So a negative sign or a subtraction sign is always glued to the thing that comes right after it. So this is a negative 5. Distribute it, and I get negative 5x plus 20. So that's like a major, like super common mistake is to not change that to a plus. And then gather all the x's on one side and non-x's on the other, combine like terms. So I'm going to have an 8x on the left. 10 plus 20 is 30, minus 6 is 24. So we get x is 3. Not good? Okay. So then the solution set is just the number 3. And to check, I just put in a 3 for x and make sure this is true. 3 times 3 plus 2 equals, does that equal 10 minus 5 times 3 minus 4? So 3 plus 2 is 5 times 3 is 15. And 3 minus 4 is negative 1. Negative 5 times negative 1 is 5. And 10 plus 5 is 15. Check. All right, so yes. Nope, these are just for your notes, not collecting the packets. Okay, so let's take a look at the solution to 1b here, this problem, this linear equation that has the parentheses. Okay, we're going to use our graphing calculator to come up with that value of x equals 3. So we're going to have the calculator, and then I'll show you how to have Geogebra do it for you as well. Okay, so step 1, we're going to enter each side of the equation separately into y1 and y2 of the graphing calculator. So basically, I'm going to graph 2 lines. Clear what's in here. I'm going to graph y1 is the left side of this equation, 3 times x plus 2. And in y2, I'm going to put the right-hand side of the equation, 10 minus 5 times x minus 4. Right. So the idea is I want to know when the two right-hand sides are equal, when does this line and this line, when do they have the same y value? So step 2, I want to use the table and the graph features to locate the x value for which the y values are the same. So I'll just use a standard window. It's always a good place to start, and you can adjust from there. And just press graph. And I've got two lines, but I can't seem to see where they cross, right? Looks like it's a little bit too high. So I'm going to adjust my window a little bit. And instead of going from -10 to 10 for y, I'll go from -10 to 20. And then maybe I'll be able to see them cross. There we go. Perfect. So I'm interested in the intersection point because at that point, the two lines have the same y value. So I could just use my trace button. If you press trace, a cursor appears on one of your lines, and you can just move it left and right with these arrow keys. So what does it look like the coordinates of that point are approximately? 3 and 15. Yeah. Right. So if you want to be a little more accurate, we happen to know the exact answer to this equation is 3. If you want to be more accurate, in the calculate menu, which is above trace, do second, calculate, choose option 5, which is intersect. It asks you, is this the first curve? Like a cursor is blinking on one of your lines and it says, is this the first line? And you say yes by pressing enter. And then the cursor jumps to the other line. There it is. And it says, is this the second curve? Because we're not always going to be dealing with lines. Sometimes they're curves, so the calculator calls it a curve. Is this the second curve? And you say yes. And then you just have to guess. You put the cursor somewhere near the place where they cross. And it says that it intersects at 3:15, 3:15. So the 3, the x equals 3 is the solution to the equation. What's the 15? It's the y value of both sides. That's what you get when you plug the 3 in to check. You get 15 equals 15. Okay, so the answer is the x coordinate of the intersection point. And just to verify, I'm going to go to the table, my graphing calculators table, second table. And I know that the 0 now is at 3. So if I type not the 0, the solution is at 3. If I put in a 3 for x and press enter, what am I going to see in y1 and y2? What are the y values going to be? 15, yeah. So, and because they are the same, that's how we know that the solution is 3. Because the because this side equals this side. They're the same. All right. So before we move on to the with fractions, let me just briefly show you how to do this same kind of thing in GeoGebra. Okay, so here's GeoGebra. I'm basically going to follow the exact same procedure I did in my graphing calculator. The steps of how you make it graph lines is a little bit different, but I'm going to graph the two lines and find the intersection point. Okay, so the first line was y equals 3 times x plus 2. So I just in the input type y equals 3 times x plus 2 and hit enter, and it graphs that line. And if I want to adjust the window, I can just drag this down, drag that down. There we go. Okay, and then my other line is 10 minus 5 times x minus 4. Y equals 10 minus 5 times x minus 4. There's my other line. And then what I need to know is the coordinates of this intersection point. The x coordinate of that intersection point is the solution. So I type intersect, square bracket, oops, square bracket, okay, and the things that I want to intersect, GeoGebra has named A and B, right? Those are the names of the lines. So I just type in A comma B. And it labels point A and gives me 3,15. So in the algebra view, I have the coordinates, and x equals 3 is the solution. So I just want to show you one little thing that will help you in your project. If you want the coordinates 3,15 to show up here in the graph, right-click on the point A, go to Object Properties, and right here where it says Show Label, we want to see the label, but instead of just the name, I'd like to see the name and the value. choose that, and then close it. And now it says A equals 3, 15. So if you want the coordinates to show up, you can do that little trick. Okay, so now we're going to deal with equations that have fractions in them. So all the rules are pretty much the same. Do the same thing to both sides, right? But now we're going to have to deal with fractions. So suppose you were asked to solve this equation. X plus 1 over 4 equals 1/6 plus 2 minus x over 3. What's the first thing you would do? Common denominator. Right? Dealing with fractions, I've got two fractions being added together. I definitely need a common denominator. So do you agree that it would be easier to solve an equation that has no fractions in it? Yeah. Don't you wish there were no fractions in this thing? I do. Okay. So is there a way to solve an equation that contains fractions without having to deal with the fractions at all? And the answer is an amazing yes. Okay. Let's see how we can make our life simpler and clear the equation of the fractions. Okay. Instead of having to get the common denominator, add the fractions, right? We're going to get rid of all the fractions. Okay, so this is the given equation. We want to multiply everything on both sides of this equation by the common denominator. What is the common denominator of 4, 6, and 3? 12. Good. So we want to multiply every term on both sides of the equation by 12. Why? It's the common denominator. Okay, this is a magical step, right? Multiply everything on both sides of this equation by 12. And you can write 12 over 1 if that helps you with multiplying fractions. So every term on both sides gets multiplied by 12 over 1. Okay, so what happens when you multiply x plus 1 over 4 by 12 over 1? You can reduce. Yeah, if you reduce before you distribute the 12, there's no more denominator, right? 12 over 4 is 3. So I just am going to say, well, think of that as 12 over 4. That's actually 3. What is 1/6 times 12? 1/6 of 12 is 2. Yep. 6 goes into 12 twice. So this is going to become a 2. And then 2 minus x over 3 times 12 over 1. What is 12 over 3 reduced to? 4. So those cancel and become a 4. And there's no more denominators, right? So all I'm left with, I know this looks like a mess, but I've got 3 times x plus 1, because my 4 canceled here. 1 over 6 times 12 equaled 2. And then my 12 over 3 reduced to a 4, so I have 4 times 2 minus x. No more denominators. No more fractions. Now we just use the distributive property. I just did this step. Yeah. Sorry. Okay, so divide out the common factors. I did that. The fractions are gone. Okay, sorry. Now use the distributive property. So I have 3x plus 3 equals 2 plus 8 minus 4x. Combine like terms, and I'm going to have 7x on the left, add 4x to both sides. 2 and 8 is 10, subtract 3 from both sides, and I get 7. So x equals 1. And it's always good practice to check your solution. Sometimes you're going to be so sure that it's right that you don't feel like it's necessary, but it's a good idea to go back to the very original equation and plug in your answer. So I have x plus 1 over 4 equaled 1/6 plus 2 minus x over 3. And I just plug in an x equals 1. So I have 1 plus 1 over 4. Does that equal 1/6 plus 2 minus 1 over 3? So 1 plus 1 over 4, that's a half. 2/4 is a half. Right? 2 minus 1 is 1. What's a sixth plus a third? It's a half. 3/6. Yeah. Because a half, a third is 2 over 6. 1 over 6 plus 2 over 6 is 3 over 6. So check. So what do you think? Does this process make a little sense? All right. Maybe you should try one before we move on. I'm going to make one up. Okay, it's possible that you could answer this without writing out all the algebra, but just so that you can practice the method, clear the fractions, and solve the resulting equation. Okay, let's do it two ways. Okay. Let's do it the old way that we would have done before today, and then we'll do it the clearing fractions way. So on the left-hand side of this equation, I have a denominator of 2 and a denominator of 8. What's the least common denominator of those two? 8. So I would multiply just this one fraction by 4 over 4. Right? So I would end up with 4x over 8 plus 3x over 8 equals 7 over 8. Now what is 4x over 8 plus 3x over 8? Over 8. Yeah, 7x over 8 equals 7 over 8. Now what do I do? You then could multiply both sides by 8. Yep, you can multiply both sides by 8. Cancel, cancel. You get 7x equals 7, x equals 1. Right? But why wait until the third or fourth step of solving to get rid of the denominators when you can get rid of them right away? Okay. So now we'll go back and do it using our new method, our new magical method to get rid of fractions. So I start with x over 2 plus 3x over 8 equals 7 over 8. And you got the common denominator. You said the common denominator of all three of those fractions is 8. Multiply every fraction, every term on both sides by 8 over 1. So when I multiply x over 2 by 8 over 1, what happens? Yeah, 8 over 2 reduces to 4, so I have 4x. And then 3x over 8 times 8 over 1, the 8's completely cancel, and I just have 3x. And 7 over 8 times 8 over 1, the 8's cancel, and I get 7. So by multiplying both sides by the common denominator first instead of last, I save myself a lot of headache in dealing with fractions. So now I just get 7x equals 7, so x equals 1. I've never had applause before. Okay, so we're going to continue with this trend, solving a rational equation, dealing with equations that have fractions. But now we're just going to throw in one more little wrinkle. The two problems we did before, the denominators were all numbers, like 4, 6, 8, they were all constants. So now we're going to learn how to solve a rational equation where the denominators have x's in them, okay, not just numbers. The procedure for solving them is very similar to solving the linear equation we did before. You still multiply both sides of the equation by the lowest common denominator. You just have to remember to exclude any variables that make values of the variable that make the denominator 0, right? We talked about that last class. So when you take a look at this first equation, 7 over 2x minus 5 over 3x equals 22/3, are there any values of x that I should not plug into one of these fractions? 0. I can't put 0 into this one or this one, right? Or the world explodes. Right? There's no no zeros in denominators. Okay, so I can't put in x equals 0. So that's the first thing I do. Before I try to do any work, I just glance at that thing and say, are there any values of x I should exclude? Now I try to solve it. So I have a 2x, a 3x, and a 3. What do you think the common denominator should be? 6x. Why not 6x squared? Yeah. So, right, I would have to do x times x for x squared. So it's kind of like when I do a third and a sixth, right? I don't have to, you could multiply the 3 and the 6 to get 18 as your common denominator, but you don't need to because you could just use 6, right? So you don't have to repeat factors, right? So I don't have to use that x twice. I only have to use it once in the common denominator. All right, so my common denominator, I'll write over here, is going to be 6x in this one. So my method is multiply every term on both sides by 6x over 1. Same thing I did before. So I'm going to have 7 over 2x times 6x over 1 minus 5 over 3x times 6x over 1 equals 22/3 times 6x over 1. Now I try to reduce and cancel things. So look at the first term here, 7 over 2x times 6x over 1. Well, 6 over 2 reduces to 3. So you say, okay, 2 goes into 2 once, and it goes into 6 3 times. And I have an x on the top and an x on the bottom, right? I can cancel those. So all I'm left with in this expression is a 7 times a 3, which is 21. Move to the next term, minus 6x over 3x. How does that reduce? What does that reduce to? 2, right? My x's cancel. And 3 goes into 3 once, and it goes into 6 2 times. So all I'm left with is 5 times 2 in the numerator, which is 10. Okay. What cancels on the right side of the equation? The 6 over the 3 reduces to a 2. So 3 goes into 3 once, and it goes into 6 2 times. And that's all I can do, right? My denominator now is just 1s, so that's the best I can do. 22 times 2 is 44, and I still have an x that did not cancel. Now I have an equation with no fractions. I can go ahead and solve it, and I get 44x equals 11, which means that x equals 4. There's my solution. One fourth, yeah. Divide both sides by 11 over 44 is 1/4. Is that okay? Because I was at 44x equals 11, right? I divide both sides by 44. Yeah, those cancel. 11 over 44 reduces to a 4th. Yeah. You're welcome. That's the danger of doing things in your head, right? Just write it down. All right, let's do one more together. And then I'll have some that you can try. All right, I have 5 over x plus 2, 3 over x minus 2, and 12 over the product, x plus 2, x minus 2. Before you do anything else, what values of x should we never plug in to this equation? 2 and negative 2. Either one would make a denominator of 0. Okay, so now we can start our work. What do you think my common denominator should be? X plus 2, x minus 2. Yeah. So this is kind of like if this were a half and this were a third and this were a sixth, right? So my half and my third multiply together to make my 1/6, and that's my common denominator. So I have 5 over x plus 2, and I have to multiply by my common denominator, x plus 2, x minus 2 over 1, plus 3 over x minus 2 times x plus 2, x minus 2 over 1 equals 12 over x plus 2, x minus 2 times the common denominator, x plus 2, x minus 2 over 1. Whew. Okay, so I multiplied every term on both sides of the equation by the common denominator. Looking at the first term, what cancels? X plus 2, so I've got 1 on top, 1 on the bottom, and I'm left with 5 times x minus 2. Next term, what cancels? X minus 2's, 1 on the bottom, 1 on the top. I'm left with 3 times x plus 2. Term on the right side of the equation, what cancels? X plus 2 and x minus 2. 1 on the bottom, 1 on the top, and I'm just left with 12. That equation, you probably could have solved years ago. Right? So just to quickly finish, 5x minus 10 plus 3x plus 6 equals 12. And so we have 8x equals 16. So x equals 2. Is that the solution? Why not? Because x can't be 2. That was like the first thing I said. X can never be 2. Did I do this all right? Negative 10 plus 6 is negative 4, right? And then I added 4 to both sides to get the 16. So what does that mean? What does it mean when, what do you say when there's no x value that will make this equation true?
They don't intersect.
Prime means you can't factor it. Parallel. Yeah. There are no solutions. There is no x value that will make this equation true. This is an excluded x value, which means there are no solutions. So that means if I graph the left side of this equation and I graph the right-hand side of this equation, they'll never touch. They never intersect. Let's look at them, because that might be interesting. So there, I've got them both graphed, but it's hard to, which one is which, it's hard to tell. So I'm going to click on this one and go Object Properties and just make it like red. So I have a red graph and a black graph, and they never touch. Crazy. Down here, they're getting really close together, but they never cross. Yeah, so you might be interested to say, do they ever cross? So like maybe I would zoom in on that area. And you see that like the more I zoom in, the more space appears between them. So they don't actually ever touch. Okay, I'd like for you guys to try C. Okay. Let me just give you one little hint. Factor x squared minus x before you do anything else. That will help you find excluded values and figure out what the common denominator is. Okay, so let's take a look at this. My hint to you was to factor x squared minus x before you do anything else. Before you do excluded values, before you start trying to solve, factor that. Okay, so 1 over x plus 1 over x squared minus x, how does that factor? X times x minus 1, good, equals 5. And it might be helpful, since we're dealing with fractions, to write 5 as a fraction, 5 over 1. Okay, what are my excluded values? What values can I not put into any of these expressions, otherwise I might get a 0 in the denominator? 0 and 1. Negative 1's fine. Where are you afraid to put negative 1? Negative 1 squared is 1, but then you do minus negative 1, which is really plus. Yeah, so negative 1 is cool. So my excluded values are just 0 and 1. All right, what's my common denominator? X times x minus 1. So you take each factor only once. So this is analogous to having, say, a third plus a sixth, right? And equals 1 or something, right? So I don't have to multiply the 3 and the 6 to make a common denominator of 18, right? You don't have to replicate factors. So this x shows up as a factor in both denominators. You only need it once in the common denominator. Okay, so my common denominator is going to be x times x minus 1. So I multiply every term on both sides by it, times x minus 1 over 1, times x minus 1 over 1, x times x minus 1 over 1. Okay, so in my first term, the x's cancel, and I'm left with a 1 times x minus 1, which is x minus 1. Next term, the x minus 1's cancel, the x's cancel, and I'm just left with a plus 1. Equals, nothing cancels on the right-hand side of the equation, and I have 5x times x minus 1. Yes. Yeah. X could be anything. We don't know what it is, and that's the whole purpose of trying to solve, figure out what x is. So no, you can't treat it as a 1. Okay, so, sorry, go ahead.
Why is it 5x equals to, say, 5 times x squared?
Well, it's the same thing. You're multiplying these 3 things together, and you can do multiplication in any order. So you could distribute the x and then distribute the 5, or you could just distribute the 5x all at once. You'll end up with the same thing in the end. Okay, so minus 1 and plus 1, those go away, right? So I have x equals 5x squared minus 5x. Okay, so what is this kind of equation called? Anybody remember from a previous class? It's a special kind of polynomial, yeah? Quadratic. This is a quadratic equation when you have an exponent of 2. So what do we do when you have an exponent of 2? Anybody remember? Nope. You can try to square root, but only if you can make it look like x squared equals a number. If you have an x term, the square rooting is unhelpful. Nobody remembers? We're going to cover this on Monday, but for a brief preview, move the x over so that one side of your equation is 0, and then factor, right? So if I wanted to factor this thing, I could take out an x, and I'd be left with 5x minus 6. And if I'm multiplying two things together, I'm multiplying an x times a 5x minus 6. I'm multiplying two numbers together, and my answer is 0. What has to be true about one of those two numbers? Has to be 0. The only way to get 0 as the answer to a multiplication problem is if one of the factors is 0. So either x equals 0 or 5x minus 6 equals 0. But what do you know about x equals 0? Excluded, not a solution. So I solve this one and I get x equals 6/5.